Coffee. It is Sheikh Adil Mahmood.
Good afternoon. I just didn't say my word.
Yes, celebrate.
Celebrate the Egyptian day.
It's ground.
He's coming, right?
It's correct. You all are apparently in excited state, right? You need to relax back. Just wait. Tell you a story of my travel to Mauritania. Mauritania is just too far away. It's West Africa, underneath Algeria, close to Western Sahara. And it's a big country, right? And nothing grows here. And they have just livestock. So much of flocks of camels and cows and you just name it. And
The men doing hijabs. The women no.
there's a lot of things happening. So Mauritanians wear a long dress, very long dress. And there are shoulders also which they keep putting it on. But the most important thing is that if you stay there for 10 days, every day is going to be meat, nothing else. Camel meat, chicken meat, beef meat, goat meat, sheep meat, meat and meat and meat, nothing. So I asked them, can I have some vegetable? I said, we have to arrange it from somewhere. Because meat is in it. Yeah, very unlike of Egyptians, who feed you with brinjals and lots of veggies and falafel. You know how to make falafel?
Yeah.
You know how to make. Who knows about falafel? You know about falafel? Okay, this is Arabic pakora.
Yeah, I did it.
Falafel.
It is bakura.
Yeah,
Without your breath.
without your breath. Okay, so good morning and Assalamu alaikum wa rahmatullahi wa barakatuh. Sabah al-Khair, and whatever in French. We are now on a very important topic of polarization transfer. And I told you that one of the most enduring problems in NMR spectroscopy, enduring means persistent, always has been that NMR is inherently insensitive technique as compared to other spectroscopic techniques such as electronic radiation, X-ray, infrared, or whatever. And we also discussed that there are factors which make NMR extremely sensitive, including the energy difference between population, which make this technique the only technique in which both energy states are populated. Therefore, the population difference is extremely low. The gyro-magnetic ratios are also weak. and in many cases, natural abundance is an issue also. But within these elements, there are some elements relatively better than the others. For instance, proton is 100% natural abundant. Okay, almost 100. And proton is a better magnet. It has 4 times larger gyromagnetic ratio as compared to carbon-13 and 10 times larger gyromagnetic ratio as compared to L15. So it is a better magnet. And we call it as a sensitive nuclei, a rich nuclei. Rich, relatively as compared to C13, which I told you is 4 times less gyromagnetic ratio, only 1% natural abundance. On top of it, not a very poor, not a very sensitive nucleus. Similarly, nitrogen 15. Nitrogen 15 is only 0.35% naturally abundant. It is 10 times less gyromagnetic ratio. But the problem is that we are interested in them. We have a lot of interest in them. We as organic chemists or biochemists or whatever, we would like to study carbon-13. We would like to study nitrogen 15 because we like to know the structures of proteins and nucleic acids and carbon framework and all that. So how to solve sensitivity problem, and we have discussed that. There are hardware solutions, money, a lot of money that you build large magnet, larger and larger magnets. You create a triprobe in which you use gaseous helium. You get some improvement of signal also. There are some software methods. Among the software methods, polarization transfer is the best one. And that has a very important role in NMR spectroscopy because I told you that polarization transfer made NMR reasonably sensitive. Every word which I try to say, I want to be careful. So I say reasonably sensitive. It doesn't mean that it becomes sensitive like UV. Can never be. Or IR, but reasonably sensitive. And the concept is very, very simple. Concept, somebody, Millers and long time ago, back in 60s, has given this concept that, signal is because of population difference. Right? Isn't it? Proton has a larger population difference, therefore it has larger signal. Carbon-13 has 1/4 of, forget the natural abundance at that time, this time, 1/4 of proton, right? If you go natural abundance, then it's 6,400. So it's all population transfer, is all population difference of polarization. Because population and polarization and NMR spectroscopy essentially same, Polarization means up and down. This is what poles means, right? The polarization difference is population difference. Okay. So when I use polarization difference, it means population difference. So you just always remember that whenever I'm talking about polarization transfer, it means population transfer. Okay. And then somewhere, somehow, someone sitting in cold winter of Switzerland has said, if it is the signal intensity is all because of population difference, why don't we just transfer the population of sensitive nuclei to insensitive nuclei? And when we do that, we'll be able to enhance the signal of insensitive. And I'm sure that he or she must have had the idea that proton is the most sensitive nucleus as compared to carbon-13 and nitrogen 15. So somehow, if we can transfer the polarization of sensitive nuclei to insensitive nucleus, then we get an in-hospital signal. And of course, this polarization transfer can only take place when they are scalarly coupled. When they're coupled. If Mahmood no Adil, only then Mahmood will give money to Adil, right? He would never be able to get accept scamming, which I'm sure he would never do. Okay, so this connection is important. More or less, as if that you have a weak battery. You have seen people using just jumpers, right? This is exactly a jumper. That you're not transferring your battery to them. It's just you have a weak battery which doesn't really allow your car to start. And then someone has a big Pajero with a very strong battery, and he or she is willing to help you, like Mahmood was willing to help until the last lecture. And you link that wire, you transfer that to weaker battery. Similarly, exactly, well, how would you do that? That was the problem. The concept is so simple. The application wasn't really that simple. And with that, people have really worked literally for years to do this thing happen. Now, I'm not really sure whether I'll be able to explain successfully to you the mechanism of transfer in a real sense, because it's a bit tricky. And polarization transfer, a lot of people try to explain it unsuccessfully. And there is no guarantee that I will be successful also. But I can always attempt. Okay. Having said that, polarization transfer, if you use, now let's spend some time today. We will be settled, we will have a deep breathing exercises, 1, 2, 3, 4, right? Keep it for 10 minutes or 4 seconds, and then deep breathe, just so relax yourself. And so we could use the bigger population difference from sensitive nuclei, proton, and pass it to the less sensitive nuclei, such as E30, hydrogen 15. The poorer the magnet, the more beneficial it would be. If Adil has very little amount of money in his account, Mahmoud's transfer of 1 million Egyptian pound would benefit him more than if he has already some amount, right? So nitrogen 15 is, now it doesn't really mean, Adil, that I'm actually propagating that. I know that you're a rich man, but just an example. Okay, so Ani is, okay, so in a predictable manner, so this cross polarization, this polarization transfer is from more sensitive nuclei to less sensitive nuclei. And this method is called polarization transfer or population transfer. Okay, and to understand how it works, let's take the example of scalarly coupled system, carbon hydrogen. As I said that this transfer can most probably takes place if there is a connection. And the scalar coupling, because polarization transfer is a bigger phenomena than what I'm presenting here. Here, my purpose is to give you an idea that polarization transfer can help in increasing the sensitivity. Polarization transfer is everything. Polarization transfer can be between the similar protons, proton-proton, like COSY. right? Polarization transfer between two protons in nosy. So polarization transfer is everywhere. But here, polarization transfer is between two different nuclei, heteronuclei, carbon hydrogen. And the objective is to enhance the signal of carbon, right? And they are coupled with each other. So there are CHs, there are CH2s, and there are CH3s. Why quadricarbon is not relevant here? Absolutely, Khalas, he has no mammoth, his friend. Nobody is willing to give him money, and therefore quadricarbon doesn't get any, fine, understand. So here quadricarbon is, and I wish to relate you. Remember that I told you in APT that there was a difficulty between distinguishing between quadricarbon and CH and CH3 and CH2, right? If you perform this experiment, just a simple one, don't be confused. In this case, you can only see CH, CH2, CH3, no quadricarbon. So if you have APTC, APT, and if you have this two experiment, you can easily recognize CH and quadricarbon. You understand? Now, I don't want to confuse you, but I'll tell you that this is what we generally do. We report various spectrum, and then we distinguish between quadricarbon. In this case, quadricarbon is not relevant because it has no one to give polarization, no proton, lonely, sad, desperate, poor quadricarbon. Always never get anything out of nowhere. So we have all the sympathy for quadricarbon, but we cannot discuss this here despite all of it. Okay, so now I'm indulging you. Yes, sir.
Since giving
Both?
the negative abundance of the proton more than carbon.
Yeah.
But the thermodynamic ratio of the proton.
So you're right. So many factors which define the sensitivity. Okay. This is your B naught, right? Okay. Proton NMR can exist alpha beta, or carbon 13 can exist alpha beta, right? If they are not coupled. If they are not coupled, then they have no relationship with each other. They can be alpha beta, beta alpha. But if they are coupled, like CH, then they would be affecting each other, right? Then you would have different combinations, such as this one. You can have carbon and proton, alpha alpha. You can have carbon and proton alpha beta. Sorry, beta beta. And you can have carbon alpha beta proton, and you can have beta carbon and alpha. Nothing but four combination. You agree? Either both down, because these are CH coupled with each other. Either both down, both up, low energy state, both down, one up, one down, and it can never be same, because these two states can never be same because C13 and proton are not same. Okay. So you have this kind of relationship for a coupled system. Uncoupled system, no relationship, nothing. So you have like this. This is carbon transition. And this is carbon transition, this is proton transition. So if you record carbon NMR spectrum, the population difference of this and population of difference of this will give you doublet. Because CH, right? Carbon would be doublet, right? And proton would also be doublet. But the signal would be 4 times higher. The population difference is more. Anyway, so this is the 4 relationship which you would have. In this case, no relationship because they're not coupled. When they're coupled, they have 4 combinations, 4 relationships. And I would try to explain to you how this polarization transfer takes place. This is what in the process of indulgence of it. And we have seen that people walk on a rope. रस्सी पे चलते हुए देखे like this. So you are like this. You are on a very tight rope. वो क़यामत में किस जगह पे जाएंगे? पुलिसर. I don't want to go to पुलिसर. You know पुलिसर? You know, no, sir. That is after that. After, no, sir. Okay, so police wrath would be they are saying that this is going to be like sharp as here, right? I don't think we are that bad now. It's that tough. You're my family, yeah, right? I don't think today is that one, but we are trying to be like this. Okay. You happy with this? Low energy state, both are alpha alpha. Assume that this is carbon, this is proton. Okay. And both beta beta. You happy with it? Yeah. And then carbon proton. And then carbon proton. You're happy with it? Okay. So the peak of the peak intensity of carbon, forget about natural abundance at this point. The intensity of the peak of carbon doublet is going to be 4 times less than proton, because gyromagnetic ratio. Okay. Now, this is the same thing which I have presented with vector. You see this, right? You see this, you see this, okay, and you see this. It's not hybridization, it's coupling. When you have a CH, C is a doublet because proton exists in 2, every proton exists in 2. Proton is doublet also because carbon exists up and down. So there are 4 combinations of it, right? Here we stuck into a situation in which we are trying to increase the population of carbon. So we are interested in carbon, right? But we have to be interested in proton also. If we are not interested in proton, how would we transfer the polarization? Either has to be good with the otherwise there would be no money transfer. Okay, so Mahmood is as relevant as Adil. We are trying to determine Adil's financial health. Okay? If you mind it, I can give my example and summary. You know, I can be carbon 13 and she can be Rotan. It's fine. I don't want to, they'll say, okay, you know, I've been pretending. So, okay, so far, happy, healthy, deep breath. Okay, so do you agree with this one? Because it's a plus magnetization vector, plus half H, plus the minus, minus, plus, minus, minus, plus. You okay with that? Because these are spin half nuclei, right? So plus half carbon, plus half H, plus negative carbon. This is orientation, right? Sign. You're okay with this? Who is not okay with it? Yes. So, you know, proton is a spin half nucleus. Spin half, you know, spin half, right? Because it exists in either up or down. Any question? No, for you.
पॉजिटिव मैं कैसे पता
No. This is the sign. Spin half nucleus. Proton is spin half nucleus. It exists either up or down, right? And when it is along the magnetic field, it's plus. When it is opposed to the magnetic field, it is minus. So carbon and proton are coupled. Carbon and proton are coupled. So carbon and proton can exist in four forms. Either both of them are up, or both of them are down, or one is up, one is down, and vice versa, right? So this is what I was trying to say. So this is proton, and this is carbon. And this is carbon transition. In this state, carbon has against and a line. Herein, now, in order to simplify it, as she asked, bit complicated, not so easy. As I said that, so there's a Sheikh, you solve the problem. Absolutely. Big magnet, which is the big magnet?
The big is the proton and the small magnet is the carbon.
Okay.
Okay. You can do in four situations.
That's a very beautiful example. You know, you have a magnet bar and both not same, right? And then you have up, then you have down, and you have one up, one down, and one up. You're so brainy. That is the problem with Yamanis. They're too brainy there. Anyway, they take a lot of coffee, and honey. And Yemeni honey can be as expensive as 1 kilogram, like $1,000. Anyway, so you happy with it? And now I say, okay, in this whole situation, add plus half H delta H and plus half delta C. Add into it. Please, Adil, you do that. In all these situations, just to simplify, nothing else. Add this into all of it. You see that? No, just add this thing into it.
It will be one. There was one.
Yeah.
One gamma.
So again, Yamanis are shining. Okay.
This is plus half gamma h, and this will be one.
Jama means Jama, right? Jama in Arabic is also Jama. Add this. Okay.
Then this will be one. One h, one gamma h, and this will be one gamma c.
Half को इसमें add कर दे, क्या होगा?
One.
Okay. Then.
This will be one gamma h, and this will be 0.
Oh, so nice. Annie.
This will be 0 gamma h, and this will be one gamma c. This will be
0, 0.
0 and this 0.
Again? You remain, stay here. I need your help. This is what he was saying, isn't it? Okay? No, it's just for simplicity and understanding. Because we were having problem with half, right? So, is this okay? Now I want you to help me further. I want delta H as 4. Magnetic ionic ratio is 4 times. Carbon as 1. You replace these numbers with this, these signs with this number. Can you do that?
Yes, now gamma h equal 4 and gamma c equal 1. Mean this will be 5.
Yeah.
Okay. Check further.
Gamma h mean this is 4.
Okay.
This gamma c mean 1. This is 1.
Okay. Now give me the population difference. I want you to do work for me. I will give you a coffee, a cup of coffee.
Okay.
Yemeni coffee.
This is 4 and this is 5. Mean 4 minus 5
The population difference?
minus
1.
1.
This one? Minus 1. Okay. This one?
This 0 and here 1 minus 1.
Okay. So it means carbon is 1 in both cases. What about proton signal?
Okay. 0 minus 4 means 4.
Okay. 4.
And here 1 and this 5 might mean 4.
Okay. I decided to sit here and let him teach. No, you should. I'm tired actually. From here. Start from here. Oh, okay. This one. You see the sign, you see the sign of magnetic power, right? Oh, it's magnetic, okay. Sure, start please. And this is a coupled system, carbon proton. Okay.
Okay, we have two nuclei, proton and carbon 13. First of all, there are 4 combinations. We have in proton alpha alpha and in carbon also alpha beta. So now, when we combine proton and carbon, there are 2 energy states, mean all in alpha or all in beta. Here, all align with magnetic field. In beta energy state, they're against or opposed. We have also two combination, mean if carbon with magnetic field, proton against, and vice versa, if proton against, mean carbon with. Mean we have two combination in middle, and we have low energy state and high energy state. Okay, now if we suppose or instead two energy state with plus half and minus half, now we have in this case with magnetic field plus half gamma H and plus half gamma C. Mean carbon and hydrogen all align with magnetic field. In beta, we have also minus half proton and minus half carbon. In this case, plus and minus mean H with magnetic field and carbon against magnetic field. Another possibility, minus half gamma H and plus half carbon. Mean we have four combination, all with or all against, one with, one against, and vice versa, one against and one with. If we now multiply this,
No,
add, if we add plus half gyromagnetic H and half gyromagnetic carbon 13, we will find this. Mean we will add and we will find one. Here carbon will remove and we will stay only H.
you add up there into all of them. Yeah, explain that now. This is very important.
Okay, when we add, mean we will find gamma C and gamma H. Here, when we add, mean we'll remove plus half carbon 13, and also we will add half proton with half proton, we will find one.
Why don't you start from here? You're adding plus half H and plus half. Okay.
When we add, we will find one in both cases. Here, when we add, we will find this
Half
one.
and half one. Okay. Half and half one. Okay, so delta H and delta C. One delta. And in this case,
Half and half one, half and minus half zero. In this case also, plus and minus will be zero, and carbon will be plus 2 plus, mean plus half and plus half will find 1. In this case, plus in two cases, proton and carbon 13 will all be 0.
understood. Shabash. You know Shabash?
Yes, sir.
What is that?
Very good.
Very good.
Shabash, Shiri.
Yeah, Shabash. Okay, now next.
Okay, in this case, we know magnetogenic ratio 1 to 4. Mean proton 4 times of carbon. If we
Just a number, just to make you understand. So this is just a number to make you understand it has a logic that gyromagnetic ratio of proton is 4 times higher than
carbon.
carbon. Okay. Because proton and carbon, the difference between them is 4 and 1. Gyromagnetic ratio, if you see the number, then carbon, proton is 4 times more gyromagnetic ratio than carbon.
Okay, now if we put gamma H4,
If you replace these
replace
with
this
this
values and gamma C1, this will be 5. And here gamma H mean this will be 4. This gamma C will be 1 and here 0. The difference between them 4, 5, 0 and 1.
It means that if you're recording carbon 13, then the signal intensity of a doublet will be,
So
the signal intensity population difference between carbon signal
it will be 1. 4 and 5 will be 1.
and
This will be 1 also.
this is another doublet. You know, this is doublet, two parts of the doublet. Okay. What about proton?
Proton 4 minus 0 will be 4, and here 1 and 5 mean the difference between 4.
So it means that assuming that carbon 13 is to get natural abundance, the peak of proton is going to be at least 4 times higher than carbon. Now, I want you to transfer this population, selective population transfer. You shift that. Okay. If you do that, you know, you take that 4 up and 0 down. This is population transfer. This is polarization transfer. That when Mahmoud is giving many to others. Okay. What will happen?
Okay, now if we shift this 4 to this position and this 5 to this position, then
No, just one.
okay, 4.
Selective population.
If we shift this to this position, will be 4 minus 0 will be 4.
Okay, so like this. You mean like this?
Yes,
So what has happened is that by some pulse, what is your name, Chef?
yeah.
Yeah. By some pulse, you have selectively inverted the population. Okay, so this 4 goes up and this 0 comes down. What would be the population difference? Sorry. Okay.
Okay, now the difference 4 plus 1, 5, and 5 mean
Carbon 13.
carbon 15 mean
The difference between carbon 13.
5.
Okay, guys, come down. Help Yahya. Someone should come. You're getting close to Islamabad, all of you.
If I understand right, my chemistry is very bad there.
This is not chemistry.
Yeah, this calculation. That's why I can't do it. Actually, from the previous slide, we changed the 4 to rather than 0. Yeah, here.
So selective population.
Selective.
I'll tell you how you do that. Don't worry about it. I'll tell you what pulse is used to transfer that.
Just your question now, what is 313, yeah?
Yeah.
It will be 5 because 5 minus 0, it will
And
be 5.
before that, how much was that?
Before it was 1.
One.
Yeah, 1,
And you
yeah.
converted 1 into 5, right? Oh, God. Miracle. Magic, right? Okay. And what about this?
Proton, this it will be 1 minus 4 or 4 minus 1. 4 minus 1 it will be 3. No. Difference, okay, 3. Minus 3. Minus 3.
And before that was?
Before was is 1.
Now you have plus 5. You have a doublet appearing plus 5 and minus 3, right? So isn't it magic that you converted 1 into 1 into 5 into 3? Even if it is a negative signal, it's big signal, right? Now you explain.
Yeah.
You are a carbon, okay? You benefited from this. You tell me how good you feel.
I increased my intensity from 1
From 1 to?
I increased my intensity from 1 to 5.
It's the sensitivity from 1 to
You are a doublet, remember? You are a doublet. So you 5 and minus 3. Okay, so doublet appearing distorted. And but it's instead of 1, it is 5. And instead of 1, it is -3, still bigger, right? You're happy?
Yes, because I increase my sensitivity.
Oh, you're happy with it?
5 times.
Okay, and you are a proton.
Yeah. Me?
Yeah, yes. What is your intensity? Before that was 4.
Before that is 4. And now also 4.
No, 4.
Yeah.
You will talk about doublet.
Yeah, same. Why I need me to be happy? Because previously it's 4
You help me.
and now
You help me be happy.
So show me that.
because if we speak about this proton, previously we like 4
minus
to
0.
0, it will be 4. And still now from 5 to still 4, right?
You did not use anything.
That's why I am same before and after, because already my sensitivity is high from the beginning. Why
I know
need to be happy?
You're very sensitive.
Yes.
Okay, yeah.
If I understand it right, I'm not sure.
Okay, so yeah. Why don't you draw on the board your sensitivity before this magic happened? Before this, what was your signal here on this? Just remove all this. Yeah, it's a carbon, right?
Yes.
Yeah. Before this thing happened. Before this thing happened. Okay.
Sir,
What was your intent?
as a signal.
As a signal, yeah?
Okay. Compared to proton, I was one approximately like this.
This is like proton and
Show me yourself as a doublet. You are your doublet. CH. You have a. Show me a doublet.
Like this.
No, it's all right. Okay, so before this magic happened. Yeah, you're not going anywhere, brother. And no, proton is not going.
It's better to sneak out.
Okay, C13 doublet and proton doublet. At least 4 times. Okay, make me after polarization transfer. I don't need it. After polarization transfer. No, not here, down there.
Okay, sir.
And use same, yeah.
Sir, I think it will be like this.
No, down to C30.
Down. Okay.
And use the pen which you have in your left hand.
كنا أحسن مش 4 واحد. بعدين نعمل أنا أحسن.
Down, exactly down.
Its intensity will be bigger.
It will be bigger 5 times.
Okay.
4 times.
Intensity of Gaia is now -3. +5. Are you happy, man?
He's happy.
He's happy, right? Now you have to explain this to everyone. I'm going home.
يا خلينا كلها هنا.
This. Yeah.
Okay, after we find this, after calculations, we find this time. 0, 4, and 1.
Down there.
13 signal will be like this. 5 minus 0 will be plus 5. And in another side, 1 minus 4 will be minus.
Right? Okay.
Okay, now I have this values. Mean this minus 3 will be in negative side, and plus 5 will be upside. And with different intensities, like this. This is minus 3 and this is my plus 5.
And that is from 1 to 1, right? From 1, you have increased it.
Yes, it was this like this. 1 plus 1 plus 1. But with help
Of proton.
proton, yes, I increase my intensity like this. Mean I will be.
And what happened for me? You,
What happened to you? Just
he, yeah, actually, we be from plus to minus 4.
same signal.
The head and there, and same.
Yeah.
Same. From positive 4 to negative 4, right?
Okay. But,
Ah.
but Amna, we don't really worry about you.
Yeah.
Our
Yes.
problem is carbon.
Carbon. Yeah.
We just wish to take the benefit of. Okay. Good. You're the smartest group of people I have ever seen in my life. And don't consider this exaggeration. You want to say something?
Yes, what?
Yeah. So you're not very happy with this signal, right? You're not very happy with this distorted signal. Nobody was happy with that. You're happy? You're still happy?
Yes, thinking about maybe swapping the signals. Cancel. Plus 5 positive, 24 minus.
You do that. But at the end of the day, the essence of this case is that you were able to convert 1:1 into 4:3, right? That is increase in sensitivity. And of course, initially people got distorted signals. Everything was distorted. If it was a quartet, 2 up, 2 down, CH2 was like 1 up, 1 down, the middle was small and all that. So that is the reason, it's called distortion. That is the reason that depth was developed. Distortionless enhancement for polarization transfer. This is distorted enhancement. Understand? Distorted enhancement is an enhancement in signal. And should be very, very happy that when people have done it, they were extremely excited because they were able to convert an insensitive signal into more, 4 times more. From 1 to plus 5 is 4 times more. From 1 to minus 3 is also 4 times. Right? Isn't it? So this will actually happen, and this was the most exciting thing happened in NMR spectroscopy in 70s when people were able to do that. Now I'll take you to the difficult part, and then how to do that. That is a problem. Yeah, I mean, when I done this, you all believed me. But how would you do that? This is a question which I don't have an answer. Okay. So and remember that you need to play with both proton and carbon. You will only detect carbon, but you have to play with proton also. Unless you play with proton, you will never be able to transfer the polarization to carbon. Although you will detect only carbon. So when I show you this pulse sequence, the detection is this one. Remember, this detection FID is represented like this. So this is the sign of detection. No detection in proton. Who cares about proton now? You know, we got benefit from, and who cares? Sorry, this is the world. This is what happened in real world. Okay, next 10 minutes are the most difficult part of our lives, and we are ready for it. You can have prayers of whatever way you would like to. Everybody should pray. Okay, so let's see what actually happened in proton, because that is what is giving the polarization. That's more important. C13 is not important. C13 is just receiving it. Okay. So excitation pulse 90x. You know, these drawings are made by me, all by hand in the book. All long time ago when I was of your age. Can you believe it? I was in your age sometime. You don't believe it, right? Okay. 90, you forget this right now. I don't want you to worry about C13 at that time, because you want to worry about proton. Proton is the one which is going to give. Okay, so 90 X pulse will bring magnetization to X5 plane, excitation pulse. Okay. Since proton is coupled with carbon, it will split, right? It will split as a doublet. And after 180 pulse, this is spinnacle pulse. Remember this, it's nothing but a spinnacle, in which you just clarify magnetic energy inhomogeneities, chemical shift difference. At some point of time, and during this delay, these doublet would be on two sides, right? One on minus x and x, right? They will spread. And at that time, if you give a 90 pulse, what will happen? If you give a 90 pulse to this, one goes there, negative, right? Now assume that this was a combination of two, right? Combination of two. And then you brought it to X5 plane. And then it starts splitting, because it's doublet. When they reach to antiphase, you give a 180, you give a 90 Y pulse. It goes up like this, right? There is the polarization transfer pulse. This pulse is the most important pulse in the world, in this experiment. Okay, I'll tell you why. Now you come to carbon 13. Carbon 13 is this poor carbon 13, right? Now you have a new radio frequency, you give radio frequencies here, and you give a 180 pulse, it come down, right? 180 pulse, you come down. But right at that time, the polarization of part of proton is transferred here. So this one doesn't belong to it. It came from where? Photon, because they're coupled system, right? And that is eventually lead to that polarization test. Understood? Okay. So let's see this once again. This proton, and remember these are two radio frequency oscillator working at different frequencies. One for proton, one for carbon. The proton 90 Hz pulse, okay, no issue. 180 just been echo, and after this delay, this would be like anti-phase. And then you give a 90 pulse, one goes up, one goes down, right? At that time, you also bring your C30. You give a 90 pulse, you give a 180 pulse, it is on negative Z direction with no component on plus Z. With no component on plus Z, right? It's only that this pulse will give a component on plus Z. That is when Mahmood transfers some money to Adil's account. That is called population transfer experiment. And after that, you just detect carbon because carbon has extra magnetization from photon. This is the easiest thing I can tell you. I can spend about 2 more weeks to explain this. But I'll tell you this thing to everyone. When I was making these pictures long time ago, like 30 years ago, by hands, these are by hand, right? I want you to start from here. But then I said, there's too much distance. So I just took up and started from here. I forgot to remove this. And it's published in the book. You're not happy, you're not, no fun, nothing. Let me explain in Arabic. Let me explain that in Urdu. मैं इसको यहाँ से मैंने बनाना शुरू किया और बनाते बनाते मुझे लगा कि इसको बहुत ज्यादा नीचे हो गया मैंने फिर यहाँ से बनाना शुरू किया इरादा था कि इसको मैं साफ कर दूं I forgot and then it published in the book. It was a Springer book, right? So it's still there. You can see this. So it has. Don't take it seriously. It's just.
And it is released for the next editions.
Editions. I don't know how many editions,
But okay, the second
I never told them, and they never realized this. And I'm sure that people who are reading this book would always be wondering, what is this? Okay. You can have the same thing with Arjun also. Okay. You can have the same thing with Arjun also. Wish to remind you that you are not detecting photon at all. There is no criteria for it. What you are doing is that you are transferring the population of polarization of proton to carbon in this shape. You can see this. This is very important. 180 X pulse bring carbon to minus 80, minus Z. And that particular complement is coming from proton. So you strengthen it. It's called selective. You can do it proton, one proton by one proton. If you like 5 protons and carbon, you can do it one after the other. But you can also have this polarization transfer for all protons. And you get, yes.
you explained before about the polarization, for instance, I see the picture shift from Z to Y.
Z to Y? Oh, this one.
The picture.
Then you don't worry, you know this, you can only record spectrum when everything in the XY plane. You need to bring it on XY. Tell us.
How we need another pulse for.
Yeah, we need to play with pulses. Remember, nothing would be recorded until you bring it on XY plane. So since you're going to record it, you need to bring it on XY plane anyway. Right? So God, I don't know. I mean, I have to, if some of you understood this concept, then I would be a very happy man. Okay. And if you don't, I still be a happy man because I would try again, inshallah. Now, this is explained one more time. This time a bit better. Okay. Proton, right? Is a doublet. Assume is a doublet, right? U is a doublet. You give X pulse, 90 X pulse. Here for clarity, I remove spin echo pulse. Because that confuses you. It has nothing but just to refocus. In experiments, in a lot of experiments, NMR experiments, में spin echo डाल देते हैं, ताकि so you in a lot of NMR experiments, you just introduce spin echo only for the purpose of combining it to remove the errors. But anyway, in this case, you're okay with that? You're happy? 90 X pulse? You're happy that this doublet is splitting? You're happy that this would eventually go to this stage? And then at this stage, if you give a 90 pulse, where it will go? You're happy with it? Okay, in C13, in C13, you give listen this. In C13 and 13. Okay, in C13 you give 180 pulse, and then a part of it is coming from here because you inverted the population. Okay, sorry about that. I think it is understood. So now this is what Yahya was trying to explain. Coupled, decoupled. If it is a coupled, doublet. If it is decoupled, singlet. Bad singlet because you don't know what this is. When you do a polarization transfer, you get +5, -3. You are happy with this comparison to this and this enhancement? And if you refocus, there are many methods available. You refocus, you get this kind of signal, which is far more intense as compared to this original signal. And if you refocus that again and decouple, you get this huge signal. But who wants to do that? I would only do it when I have APT connected with it because I want to know which is up and which is down. I don't want to lose the multiplicity.
Fine.
You're like, okay with this? C13. Couple. Decoupled, polarization transfer, distorted signal. And then, of course, there are new pulse sequences available which refocus them on one phase. And you can decouple and do that also. But if you combine this experiment with APT at the end, you'll be able to see CH3 and CH down and CH2 up No quadric carbon. Okay? No quadric carbon. So you recognize quadric carbon and CH2 right away. Because CH2, you know in depth, CH2 is visible on one side, quadric carbon is gone. So you know quadric carbon because you have recorded NMR spectrum. And now you're left with CH3 and CH. And for that also they are experimental. So eventually, you get this type of spectrum. But this molecule, this is fully decomposed spectrum. Right? Each carbon, one signal. Depth 135. You have no quadric carbon. You don't see quadric carbon here, right? But you see that CH2s are coming down, CH3 and CH is coming up. So you're able to distinguish from 4 groups, quadric carbon, CH2s. Still problem is CH3 and CH because of the same side, right? So you do a 90 pass, you get only CH. So this is the philosophy. The philosophy is simple. Pollination transfer help to improve the sensitivity. APT help you to distinguish between them up and down. Done? Class, meet inshallah on Saturday. Thank you, sir. Thank you, madam. I'm so grateful. Okay, so when they go to Islamabad, they'll get a bigger room. Some VIP treatment.
Because I have Yahya.
Yeah. And yeah. Yeah, will get a bigger room also. Not so big enough that you can walk, or you can still. Thank you very much. Thank you. Thank you.
Okay.